Hello, good evening all. So is this screen my visible and am I audible? You can write in the chat box or you can also use your mic also. Okay, fine. So we'll start within 2 minutes. Maybe another participant will join. So let us wait 2 minutes more. Or you can read first question, and if you know the answer, you just try to write your answer in the chat box. Also, you just think about it. The question number first. Okay, so let us start. The first question is the flow depth after hydraulic jump. Let me just go on the slide and just select the pen. The first question, the depth of flow after hydraulic jump. So here you have this option, and what is D1, D2? Let me just explain you. Very simple. Let us suppose this is a bed, horizontal bed, and you have some gate here like that, and water level is here. Gate is open. So now this will create a hydraulic jump here, and after that this is your, so this is your before hydraulic jump, this is your after hydraulic jump, D2. So these are the depth. Now just we have to tell here the relation between D1 and D2. What will be the relation? And these two depth known as your secant depth, remember please. Anyway, I'll come back. uh, I'll come in the next question, maybe the another questions. I have question based on that. Okay, so please just try to write your answer in the chat box. Which option will be correct for question number 1? Anyone please just try to write your answer in the chat box. Which option will be correct for question number 1? Okay, you are telling, Deep is telling option A is correct. Okay, D2 is equal to D1 by 2. Okay, you are telling this one. root 1 plus 8 FER1 square. Okay, FE1 square minus 1. Okay, Kagin is also telling A option. Okay, fine. Okay, so let me just explain you. So the relation between your D1 and D2, one thing always remember please. If you have the D2 is equal to this side, D1 will come. If D1 is coming this side, just for your how you will remember, maybe sometimes the student forget during the examination. So always remember if D1 right hand side, so this within the your under root, your the fruit number will be for corresponding to D1, corresponding to depth 1. Remember please, this is 1 plus 8 FR or FE square, you can say here 1. Remember these things, minus 1. So always remember. Okay, so option, your many students are telling option A is correct. Yes, option A is correct for this question. Always remember please, this is a very fundamental and very important formula for your the open channel hydraulics. Most of the question comes from this, based on this formula or another formula, your yc is equal to q square by g, which we have discussed a lot in the week number 6. And your one relation is energy equation, specific energy, y plus v square by 2g. Sometimes in the question alpha will be given, so you can consider also. Okay, so now let us move on the next one. So next question is, when the depth of flow change gradually, remember please, over a length of channel, then the flow will be termed as rapidly varied flow, critical flow, gradually varied flow, uniform flow. So you remember please, here the flow is changing gradually, whether it will be uniform, gradually, critical, or the rapid. Which option will be correct for this question? For question number 2. Just try to explain, please. Not explain, just try to write here. No need to explain. Okay, Hagen is telling C option. Okay, fine. Gradually varied flow. Other student, please also try to write your answer in the chat box. Okay. So Shreya is telling option C, gradually varied flow. Yes, because as question also the term gradually used in the question, so you can guess from the question. The concept here is, let me just explain you. Let us suppose you have a dam, you have a dam or barrier, you can say. You have barrier like that. This is your upstream, and water is filled, then go in the downstream like that. This is your downstream. So what will happen if the depth will go like that? Slightly increase, slightly increase, slightly increase, like that. That is gradually increase. What is rapidly increase? Here you can see within a short span of length, d1 to d2, if this is your 10 centimeters, so this is your around 1 meter. So here you can say like that. So this is the your basic understanding the gradually varied flow. Yes, definitely the answer for this question will be C, the gradually varied flow. Now let us move on the next one. Next question is, okay, question 3. Which of the following assumption about a gradually varied flow is false? Which of the following assumption about a gradually varied flow is false? Channel is prismatic, pressure distribution is hydrostatic. Option C, pressure flow characteristics change with time. Option D, roughness coefficient is constant. So you have the four options. So please just try to think, or if you remember the derivation of GVF profile formula, so you can definitely able to give the answer. Otherwise you just think, if you will think very in terms of the your open channel hydraulics or the fluid mechanics, you are able to give the answer. Okay, so please just try to write the answer for question number 6. Okay, Deep is telling C option, flow characteristics change with time. Okay. Other student, please also just try to write your answer. Okay, Kagan is also telling C option. That is good. Okay, flow is steady. Okay, but in question option C, the option is indicating towards the unsteady flow, right? So you are telling the assumption should be a steady flow. Okay, so let me just move. Yes, so here your option C is correct for question number 3. Always remember, please. Now let us move on the next question. Yeah, next question is bit calculative. So just ready with your calculator, your copy pen, and I suggest you, if you are looking for gate examination, so you use the gate calculator. Otherwise you can use your normal calculator, no issue. So now calculate the value of SF. SF here is your the energy slope for a trapezoidal channel having depth 2 meter, width 5 meter, slope 1 is to 1.5, 1 horizontal and 1.5 vertical. Given dy by dx is equal to 1.18 into 10 raised to minus 3, S naught is equal to 1 in 1000, and S naught here is your bed slope. Remember please, this is your energy slope. Here you need to calculate. And C is, I don't know what is C here. C may be the constant. Okay, so please just try to calculate your the SF value. You have another 2-3 minutes, just please try to calculate. Okay, so let me just explain you. The question is not uh, very hard, very tough, or very easy. So here you just remember one formula. What is formula? dy by dx is equal to nothing but is equal to your the slope difference of slope divided by 1 minus fr square. So that's it. This is the formula. So now you have the trapezoidal channel. So let me just draw. This is your trapezoidal channel. Remember, the having the depth of flow is 2 meter and the width 5 meter. Slope 1 is to 1.5. This slope you have 1 is to 1.5 means if you are moving here, just remember please, 1 horizontal is equal to 1.5 vertical. Remember. So here we need to calculate that this one. Top width. So how we will calculate? We need this much, this horizontal length. So we are moving 1 point. If you will move 1.5 vertical, so you will get 1 meter horizontal move. But here you have moved 2 meter. So what you will do? If you have moved 2 meter vertically, so just here you need to calculate 1 vertical divided by 1.5 horizontal. Now 2 vertical is 1 divided by 1.5 into 2. So this value will be there. Let us suppose when you are moving 2 vertical, so it is coming around 1 divided by 1.5 into 2, this much your horizontal distance. So now you can, after the calculation, you can put here, and now the calculation is very easy. So let me just show you. Okay, so your delta S is nothing but delta S, you can write difference between your bed minus energy slope. Now what is FR? FR you know already, V divided by root ZD. What is D? D is nothing but area by top width. Now this is your V square, remember please, and okay, so this is FR square. FR square means V square divided by G A by T. You can write FR square is equal to this. When you will convert this value, this formula in the discharge, in terms of discharge, you will get discharge is equal to what? Area into velocity. So velocity is nothing but discharge by area. So discharge square divided by area square, and this is already area in the denominator, so area cube, and this T will be go in the numerator, and this will. So this is written here. You can see very clearly. Now, how you will calculate this your perimeter and how you will calculate the area? So you know very well that these are the very simple formula for the trapezoidal. And what is your discharge? How you will calculate discharge? Okay. So here C was given your constant, chase is constant. Remember, please. So in the question that should be mentioned, the C is a chase is constant. So you have the clue for calculating the discharge. Okay. So discharge formula is area into velocity, and velocity using the chassis is nothing but chassis constant divided by into hydraulic radius S naught. So here the calculation is very long. Only a 2 and 3 step calculation will be done, is done in this here in the solution, but the calculation is little bit more, so you can explore the things. So this is the concept behind it, how I will approach the question. I have explained you, so you can follow. Now here answer is uh, first option. So 0.0004 times 0 and 1. Okay, so now we'll move on the next question. Question number 5. Again we have one numerical. So again you have 5 minutes for this. Question number 5 is a 2-meter wide rectangular channel flowing of its normal depth of 1.2 meter carries a discharge of 6 meter cube per second. Okay, so you have normal depth in a rectangular channel and discharge 6 meter cube per second. Okay, if at a section the depth of flow is 1.1 meter, the water surface at that location is a part of gradually varied flow of, means the which type of gradually varied flow, whether it is M2, C2, M1, S2. Very interesting question. So please just try to calculate. Question is very easy. So please just try to calculate, and just think on that, how we will calculate, how we will approach. At least if you are not able to calculate, so at least you just try to how to approach the question. This will be appreciable also. Okay, so let me just explain you. Very easy question. So here you have one rectangular channel. I'll just draw a longitudinal profile here like that. And within this you have flow depth something. How much? The normal depth is, within this you have the normal depth 1.2 meter, and at a section the depth of flow is 1 point. Let us suppose at this section your depth is, your y is 1.1. Now let us suppose you have the bed profile and this is your normal depth yn, which is equal to 1.1, which is equal to 1.2 meter, not 1.2 meter. Now at a particular section your depth of the flow is 1.1 meter. Then now you have to tell the gradually varied profile. So how we will calculate? So now using these two uh, data to depth, we cannot uh, able to predict whether which this your which profile will be occurring here, which profile is occurring. So what you will do? So for this actually we need to calculate critical depth, q square by g to the power 1 by 5. Let us suppose critical depth is coming around 0.5, just suppose. So what you will do, your yn is greater than in between y, then your yc, because this is your 1.2, then 1.1, then 0.5. So now based on this we can tell whether which profile is occurring here. So now first we have to calculate the yc. Now the here how we will calculate the yc? Discharge value is given, b is given. So what will be the q? Q is nothing but 6 by your 2, which is 3 meter square per second. So you can put here the 3 by 9.81, not 1.5, this is power 1 by 3, remember please, power 1 by 3. So now after the calculation, what you will get here, let me just show you. I'm not going to calculate here. So you will get 0.972 your yc value. So again your yn is 1.2, y is given in the question 1.1, and yc is coming 0.97. So this is combination is here. Now this combination is possible in mild slope. What is mild slope? This is your slope. In mild slope, this is your yn, this is your yc. Now your, and what is steep slope? This is your mild. Now steep slope, this is your steep. So here you have critical yc, then within this you have normal. So remember please. And what is your critical? So at critical, your, this is your critical and this is your normal. So here you have C1, here you have C3, here you have M1, M2, M3, S1, S2, S3, like that you have. Okay, so remember please. Now just based on this analysis, based on this observation, you can tell very easily. Let us suppose whether it is here your yn is greater than yc. Remember please, yn is greater than yc means your yn line above the yc. If it is like that above the yc, so this should be not only remaining your this one. Now your depth, actual depth is lying with your not, this is 1.2, it is 1.1, so it will be here 1.1. So now you can tell very easily the answer will be M2. So hope you understand the concept. Okay. So now let us move on the next question. Very easy question. Yes, again you have to calculate something. So let me just read the question very clearly. Determine the rate of change of depth of rectangular channel having dimension 2 meter is 2 meter into 3 meter, and the velocity of flow is 2 meter per second given s naught is equal to 1 in 500, sf is equal to 0.0007. So now you need to calculate the rate of change of depth of rectangular channel. So please just everyone please try to calculate. Okay, you are telling the subcritical flow. Okay, fine. So now please question 6, please everyone just try to solve. Very easy question. So again you have 2-3 minutes, so please just try to calculate. Anyone please just try to write your answer. So again here you need to apply whatever I think in the question number second or third, I don't know, I don't remember. So you apply the same formula. What was the dy by dx? Okay, let me just explain you. No issue. So these are questions are very important. So you please always remember, and you have to have practice such type of questions. Also, you just when I will upload this PDF, so please you follow. You just try to solve by yourself these questions. Okay, so I was telling you have to apply this formula dy by dx everything. Okay, so here in the question is given you have the rectangular channel. So in the rectangular channel fr you can write very easily v divided by g into flow depth. Let us suppose y, because a by t is nothing but b into y divided by b. So b will cancel out, it is equal to d is equal to y, so that's why here is y. Now your s naught is given and you have to calculate dy by dx. So s naught is 1 is to 500, so you can write like that also, minus 0.0007 1 minus fr square, means v square by zy. So v here is in the question is given 2 meter per second, divided by g 9.81, depth of the channel. Okay, so here you have the determine the rate of change of depth of a rectangular channel having the dimension. This is means like that, the cross sectional dimension here it is given. So this 2 maybe here is your depth and 3 may be the your width. Okay, but here very clearly not written. Okay, so you just try uh, after putting at the place of y you can put the 2, then you will just try to check by 3, because here it is not given very clearly which one is length and which one is depth, that should be given. Okay, so after calculation you will get your changing with the rate of change is 1.63 meter. So that should be your option B is correct for this question. Now the next question is very easy question. The phenomenon occurring in an open channel when a rapid flow, remember please, earlier we were talking about gradually varied flow, now we are talking about the rapidly flowing stream abruptly change to slowly flowing stream, causing a distinct rise of liquid surfaces, uniform flow, critical discharge, hydraulic jump, none of the above. So please just try to write your answer. So for question, Kagan is telling option C is correct. Okay, I am waiting for other also. So other please, if you know, you just try to write your answer. Otherwise, I'll wait 1 minute. Then after I'll explain. Read question very carefully. Also, I have given earlier hint about it. So okay. So please just think yourself. Then I'll explain. Okay. So let me just show you or explain you. So the question is your flow is initially rapid rapid flow, means very fast. Then suddenly it change in the slow stream, like earlier also I have explained you. After putting the gate, your here velocity is very high, rapid flow, but after a certain length your flow is steady, that is very slow, and the distinct rise of liquid. Here you can say very clearly the liquid, if this is your bed, here the depth is this much, but here abruptly change within a short period, within a short length. So the question is asking about, the question is telling this, and this is your nothing but your hydraulic jump. So always remember. So option C will be correct here. Yes, Kagan is correct. Now we'll move on the next question. Next question is also very easy. For horizontal and adverse slopes, initially I was just explained you about the initially, yes, I was explaining about your critical slope, your mild slope, and steep slope. Now, the question is from another slope, horizontal and adverse slopes. Here you need to fill the blank. Depth does not exist. Critical, subcritical, supercritical, normal. Means you have the horizontal and adverse slope. In such situations, which type of flow not possible? Critical, subcritical, or supercritical, or normal? Which one? Okay. So normal. Kagan is telling normal and Deep is telling like paras. Okay. Yeah, just you can uh, assume just downstream, not just downstream of the paras, but at the location of just where the water fall from upstream to downstream, you can see very clearly the hydraulic jump. Hydraulic jump is nothing but the water jump from this location, water jump to this location, that is the jump. Yes, you can observe near the barrage. Okay, so Kagan is telling for question number 8, normal depth. Okay, normal depth not possible. Other others thinking what? Please just you write your answer. I'll show you the profile how it will look like. So initially just I want answer from your side, then I'll explain. So again today also I have the three set. So we'll solve all three sets. Anyone please? Okay. Normal depth does not exist. Fine. So yes, definitely for these two type of slope, normal depth not exist. Let me just explain you how it look like. So let us suppose this is your horizontal, complete horizontal. So in case of horizontal, let us, this is your one profile. Now your normal depth somewhere yn infinity, that is not exist. Remember please, this is your critical line, critical depth. In adverse, what is adverse? The slope against the flow. Here the water is flowing this direction, slope against the flow. So here is the similar, here also your normal depth not possible. your YC is possible, but normal depth is not possible. So what you will do? Okay, so this is just observation, nothing can do. Okay, so always remember, so here H2 will possible and H3 will possible. Here similarly A2 and A3 will be possible, not A1 and H1, not possible, please, not possible, always remember. Okay, so move another question, let me just move. Okay, the question is, a 3-meter wide rectangular channel flowing at a normal depth of 0.8 meter carries discharge 9.5 meter cube per second. The channel slope is what? Whether mild, steep, adverse, critical. So I need answer for this question from all of you, please. Just put your effort and try to solve. If you are not able to, okay, fine, no issue. But at least you just try to solve the question. At least you please you just show your effort to solve the question. Whether you will get the solution or not is a different thing. The main thing here, whether you are putting effort or not. Okay, so please just try to calculate. You have another 5 minutes for this question. Okay, so now let us just, I want to solve this question, question number 9. So here you have the 3-meter wide rectangular channel, okay, and the depth is 0.8. discharge is given, the channel slope. So as I have told you, for your channel, for calculating the channel slope, you need your critical flow. For just based on your depth, based on the depth value, if you want to classify the slope of the channel, so you must, or you need to calculate your the critical depth. So this is nothing but your q square by g power 1 by 3. What is q? 9.5 divided by your width is 3. So whatever we get. So now here you can get the your yc. Now another, your flow depth is normal depth is given 0.8. Now what you will do, just let me just show you. So after the calculation you will get 1, yc is equal to 1. Now since in the question is given what, this value is 0.8 meter y normal, and your yc is how much, 1. So what you will do, your yc is greater than yn. So in such situation I have explained you already, this is your yc, and in case of steep, yc, and here is your yn. This is your yn and this much your yc. So here the same situation is, yc is here the situation, yc is greater than this, yc is greater than yn, and you are looking here the same situation in the question. So now what will be the your correct one? That is the steep slope. So always remember how you will calculate. Now let us move on the next question. Next question is, okay, so the second depth ratio of a horizontal, not horizontal, the second depth ratio of the hydraulic jump in a rectangular channel is 20. Depth ratio is given, remember. The fruit number at the beginning of the jump is, the fruit number at the beginning of the jump, you know already what is the beginning, which one is the last. Already I have explained you in the first question, I think. So please just try to use the same formula and everything. Just use your brain and little bit calculator and all. You definitely will be able to give the answer for this question. Question number 10. You have 5 minutes. Please just try to calculate. Okay, so let me just calculate. Very easy question again. So as I have told you, here you have to use the same formula. What? Your d2 by d1 is equal to half root under 1 plus 8 if r1, here you need to calculate, if r1 is square minus 1. So this is the formula. Now the ratio is given, which is your 20. 1 by 2, 8 if r1, if here what is question, the fruit number is asking. So very easily you can calculate f r1 from here. Just simple calculation. So this was the concept behind the question, how we will solve. Now very easy. Once we will calculate, you will get your fruit number 14.49. That is 14.5. Round off up to one decimal place. So for question number 10, your option C is correct. So hope you understand all the concepts and all. Now we'll move on the next one. Here is the next question. So you just please try to read the question and try to solve. I'll take here 5-minute break. So if anyone want to take the break, you can take. Okay, you are getting the 15. That is fine. No issue. 15. But in the question is coming 14.49. So maybe just slightly check your the calculation. So hope you will get. Okay, if you are getting the 15, maybe, or please remember, here is the secant depth ratio of the hydraulic jump in a rectangular channel is 20. Maybe, remember please, when you will get the 20, one thing also remember here, very interesting thing, your D1 is less, your D1 is less compared to your D2. So once you will put the maximum value in the numerator and the smallest value in the denominator, then you will get only this 20. Remember, if you will put this is the bigger one in numerator and the smaller one in the denominator, then you will get the bigger value. So that's why d2 by d1 here you need to write. So just check your calculation. So hope you will get. Now just please try to read as I have told you. I'll take the 5. Okay, fine. So 14.5 is coming. Nice. So now let us. Okay, now I'll take the 5-minute break. So you can also take. We'll meet. Okay, I'm going for the break. Okay, so now let us focus on the question. The first question is, if the value of rate of change of specific energy is 7.03 into 10 raised to minus 4 meter, and SF, your friction slope, is 0.00013, calculate the value of bed slope. So here you need to calculate bed slope for question number 1. So very easy. So please just try to calculate the answer for first question. If the value of rate of change of a specific energy is 7.03 into 10 raised to minus 4 and friction slope is given 0.00013, then you need to calculate the bed slope. S naught. Means I am representing with the S naught, you can use the SB also, no issue. So please just try to calculate the answer for the first question. I'll give you 2-3 minutes. So within 2-3 minutes, please just try to calculate. Okay, so let me just solve. So in the question is given now, initially the we were solved the dy by dx. Now here is the things is changed. Specific energy, rate of change of specific energy means d by dx. In the question is given. Not need to, question is given what 7.03 into 10 raised to minus 4 meter. Why it is meter? If the value of rate of change of a specific energy is okay, fine. Now SF in the question is given 0.00013. You need to calculate S naught. So the formula for this SE by S dx is nothing but your, that is a slope difference, nothing but. This is the energy. So now you can follow this. So your specific energy actually here is, I think this should be not there, because as you know specific energy, the formula is y plus v square by 2z if alpha is equal to 1, means this is the unit of meter and also you are dividing with the meter, so this should be not there. 7.03 into 10 raised to minus 4, and S naught you need to calculate, and SF is given. Very simple calculation. So 7.03 into 10 raised to minus 4 is equal to S naught need to calculate, and this is given 0.00013. So from here very easily you can calculate the S naught. So which will be your option C is correct here. 1 is to 1 in 1200. Now question number 2. So when a hydraulic jump is in a moving form is called, when a hydraulic jump is in moving form, that is moving forward, negative, positive, turbulent, accelerated surge in the moving form, remember please. Very interesting question. So please just try to think and try to write your answer in the chat box for question number 2. Oh, okay, Deep is telling the positive surge. Nice. Other student, please. Positive surge you are telling. Okay, fine. Okay, Kagan is telling B option. Fine. Positive surge. Okay. Yes. So when your hydraulic jump in the moving form, always remember that will be the positive. Detailed solution, when the hydraulic jump is dynamic or moving, it is called a positive surge. Hydraulic jump can be stationary, dynamic. The hydraulic jump can be described using the same analytical approaches. Okay, so remember. Now we'll move on the next question. Question number 3. A fluid height before the hydraulic jump is normal, low, high, zero. Comparatively, here you need to tell before the hydraulic jump. Everyone, please just think on that. I have earlier explained also graphically and all. So if you will think, definitely you are able to give the answer for this question. Question number 3. Low, okay. Before the hydraulic jump is low, and after the hydraulic jump it should be, if low, then after hydraulic jump should be low, high. Okay. So you both are telling option means B option is correct, low. Okay. So yes, it should be low. Option B is correct here. Oh, but in the answer option C, it should be not C. It is B. Option B is correct. Should be low. Okay, what is the detailed solution? The hydraulic jump is not possible when the initial speed is less than the critical speed. There is a transition that is created using the change. Okay, the transition appear as an undulating wave. The fluid height after hydraulic jump is high. Okay, the fluid height after hydraulic jump is high, but question was about fluid height before the hydraulic jump is low. It should not be high. Okay, explanation is given fine, but at the place of before, here should be the after. It should be the after, then option C is correct, no issue for question number 3, because in explanation it is explaining the solution was, the detailed solution is explaining here the high after the hydraulic jump. So maybe here the typing mistake, or okay, no issue. So if it is before, then low. If it is after, then high. So okay, so now we'll move on the next one. Okay, so here it is visible answer and all. Question 4, the energy is not conserved throughout the hydraulic jump is true, false? So it is true. Why not uh, energy conserved? I'll explain you. So as I have already explained many times, 2 to 3 times. So let us assume here you have the gate. So water depth and fluid is going like that. Right. So what's happened? At this location, your energy loses in form of your jump. In form of jump, energy loses. So what? The question is about energy is not conserved throughout the hydraulic jump. Yes, not conserved. Why? Because the jump occurring here, and during the jump, the energy loses. One numerical also I have, and the formula, the how much energy loses. So I'll show you. We'll solve. Okay, so this is the concept. Now that's why for calculating your D1 and D2, this is your D1 and D2, we use the momentum formula, conservation of momentum principle at the place of energy. Why? Because energy here not conserved. So that's why. Okay, so what is detailed solution? Hydraulic jump is not possible when the initial speed, okay, the through momentum is conserved throughout the hydraulic jump, energy not conserved. So that is I was explaining. Now let us move on the next one. Okay, so next one also here you are able to see the answer, no issue. So question 5, The calculate the mean hydraulic depth of a channel having the top width of 7 meter and the cross sectional area 35 meter square. So you need to calculate the hydraulic mean hydraulic depth means R. So area by perimeter. Not here. Hydraulic mean radius here you need to not calculate. Here the calculation is hydraulic depth. Remember please. So D is equal to A by T. So area is 35 and T is your 7. So it will become 5. Remember please, mean hydraulic depth or hydraulic, when the question asks about the radius, hydraulic mean radius, hydraulic radius, then you will apply the area by perimeter. Now we'll move on the next one. Next question. What is the Froude number for a channel having mean velocity 4.34 meter per second, V mean, and the mean hydraulic depth D is equal to 3 meter? Then you need to calculate FR. Now please I need answer from your side. So please just try to calculate. Very easy question, very simple question even you can say. But I need answer from your side for question number 6. Okay, so Bala is telling option or 0.8. Okay, fine. Other student please. Very easy question. You have to remember the formula and slightly calculation. So I need please answer from all side or all of the participants. Okay, 0.8. Ghost is telling, okay, fine. Okay, so just let me show you the answer or just very easy. So I'll also tell you the how we will calculate. Yes, option D is correct. How? Your FR is nothing but V divided by 4.34 divided by 9.81 into 3. So after the calculation you will get 0.8. What is this? Why meter here? Question is asking me what is Froude number for the channel having the mean velocity and hydraulic velocity. Why this is meter? The option is not correct. The Froude numbers is not in meter. The diamond is non-diamond. Okay, so maybe some mistake, typo mistake and all. No issue. Okay, yes, following the solution also someone did it. Okay. Okay, so let us move on the next one. Question number 7. So here, calculate the mean hydraulic radius for the channel having area 20 meter square, cross sectional area, okay, and 50 meter of the weighted perimeter. So here you need to calculate hydraulic mean radius. Previously we were calculating hydraulic mean depth, now radius. Again you have 2 minutes. Within 2 minutes please, you can calculate very easy. Pala is telling for 7a, okay, 0.4 meter. This is very easy question. If you have not calculator, so also you can calculate very easy, because this is not a, here the calculation is very easy also. The divisible numerator and denominator, so no issue. You need to have slight, okay. Deep is also telling 0.4, okay, a option. Other student, please also just try to write your answer. These are the very easy question. If you are not able to give the answer, okay, Kagan is telling A, okay, most of the all of you are telling A option, so definitely it will be A. How? Radius, hydraulic mean radius is nothing but area by perimeter, so 20 divided by 50. So here 0.4. This should be in meter. Okay, so next question is question number 8. When the energy is at minimum, when the energy is at minimum for flow discharge, it is called normal depth, roughness, critical depth, hydraulic radius. When the energy is at minimum for the flow discharge is called which type of depth? This is just definition. Okay, 8C critical depth, okay. Bala is telling C option critical, and Deep is also telling critical, okay. Other please just think and try to write. When the energy at minimum for flow discharge, let us suppose you have the 20 meter cube per second, and for that or discharge at minimum energy, which type of depth you will get? So this is the question. Or at what depth your energy will be minimum? That should be the correct way. If you have the discharge 20 meter cube per second, at what depth you should maintain in the channel, so energy will be minimum, so should not be problem. At least minimum please. So 2 student telling critical, okay. Now based on this we have formula, this numerical also, so I'll show you, we'll discuss. Okay, so definitely this is your critical one, remember. Now question number 9. You have calculate the maximum discharge through a triangular channel having a side slope 1:2 and the critical depth is 3 meters. YC is given 3 meter. Here you need to calculate the maximum discharge. So now you can correlate question number 8 with the question number 9 and think and try to calculate. Question number 9. Very easy question. Please just try to calculate. You have 2-3 minutes, so within 2-3 minutes just try to calculate. Okay, so let me just calculate. So here you need to calculate the Q max. As you know, the Q max is occur for a given, what we have just read in the previous question. When the energy is minimum, when the energy is at minimum for flow discharge is called the critical depth. So here, if you want the maximum discharge, so and you have the critical depth, so what should be the your energy? What should be the your energy? That is, or this discharge is maximum discharge is possible when you have the your critical, That is your fluid number 1. That is critical flow. Critical flow. At critical flow, as we have here seen, at critical flow, for a particular discharge, your energy is minimum. Now, here is calculate the maximum discharge through a triangular channel having the side slope this 1 horizontal to vertical, and the critical depth is given 0.3 meter. So at critical depth your energy is minimum and your discharge will be the maximum. So we'll follow, that is the your when the flow is critical means Fr value is 1. So what is Fr? V by root G, GD. What is D? A by T. What is V? Q by A. So you can put here square root, when you will square root both side. So V square means the Q square by A square, G A by T is equal to 1. So you can write very easily Q square by G A cube by T is equal to 1. So now you can write these things from here. Q square by G, then A cube by T. Now what is A? For a triangular, so you very easy you can calculate, you know everything. And what will be the your T also you can calculate very easy. So now you can put here Q is equal to A cube G A cube by T, very easy you can calculate. So this was the concept behind. Now let me just tell you how I will calculate the area. If this is your, in the question very clearly given, 1 horizontal means 2 vertical, or 2 vertical means 1 horizontal. If the depth is given 3 meter, so you are moving, you are going upward 3 meter. So what will be the this horizontal moving? 2 meter movement in vertical, the movement, the corresponding movement horizontally 1 meter. For 1 meter, 1 meter vertical. So for 3 meter vertical is how much? 1.5. 1.5 here, 1.5. So you can very easily now calculate. Very easy now you can calculate. Area is nothing but half B into H. B is given what? If you will calculate the first half, I am telling why, because this is very, if someone not able to calculate, that's why I am telling very simple, in the simple way. So half B is 1.5, H is 3. Similarly you have the two triangles, so you just multiply with the 2. When you will multiply with the 2, so what will be remain? So this will come around 2 will be cancelled out, and 1.5 and 3 will come 4.5. Similarly you can calculate the T value. T is nothing but this is, T is nothing but your top width. So what is top width? Is 3, as you have calculated 1.5, 1.5, T is 3. So everything in your hand, now you can very easily calculate. Okay. So here perimeter not required. Once you require the perimeter, then you have to calculate these length you need to, but here not required. Okay, so now we'll move on the next question. Very easy question again. So the critical depth and base width of a trapezoidal channel is 2 meter and 5 meter respectively. Calculate maximum discharge if the side slope of the channel is 1 horizontal, 2 vertical. So again you have the four option. So please just try to calculate the answer for this question. For question number 10. Okay, your Shreya, you are telling your answer is 16.27. Okay, so maybe you are on the right way, but something you just check the calculation part. So hope your answer will be match, or maybe chance this calculation may also be slight bit differ. So you just recheck your answer, recheck the calculation part. Okay, so now you can also focus question number 10. So here you need to calculate the maximum discharge. Side slope is given, one is to one horizontal, two vertical again. So within 5 minutes, please just try to calculate this question. Okay, so Bala is telling 49.21 means option C is correct. Fine. Other student, please also try to write your answer for question number 10. Okay. Here you have trapezoidal geometry, so very carefully you calculate. If you will think very carefully, so only the dimension of the geometry change. I think you have the previous question, question 9 and question 10 more or less similar. Let me just show you. Yes, it's similar. You can just see. So here I'll not again explain how this formula come. Only I'll explain one thing. Those who are not able to calculate the geometry part. So this is your trapezoidal, and this is again given, and the channel base width is given 5, and critical depth is given 2, and one horizontal, two vertical. Means when you are going vertically 2, so you going horizontally 1, that is 1. Again here also 1. So the top width is 5 and these two 7. So here you can see your T is coming 7, and your area you can calculate very easy. Half top plus base into H. So half 7 plus 5 into 2. 2 will be cancelled out. So 7 5 will be 12 meter square. So you can calculate in this way, very simple way, or you can calculate this way also. Now only the calculation thing. So after the calculation you will get 49.21. Okay, nice. So let us move on the next question. Next question is the hydraulically the economical section of drain for large flow is V-shaped, rectangular, oval shape, circular. For hydraulically the economical section of drains for large flow, not small. So please just try to write your answer in the chat box for question number 11. For question number 11, please just try to write. Now in this set we have 12 questions, so another one question we have. After that I have another one set of questions, so I'll show you each question and I'll tell you the concept how you will go through. Then once you will solve, then you are not able to. Okay, you are telling the C option. Bala is telling C. D option. Okay, nice. So once when I'll explain the concept for the next set, so once you will solve it by yourself, so you'll not get confused or not get any stuck during the solution. Okay, so let us move on next one. So yes, the D of your for economical we need to go for the D. So here detailed solution is given. A section is said to be economical when its construction cost is minimum for a given discharge. V-shaped section is usually basically for low discharge, generally present in valley. Rectangular section used for the medium discharge. Oval shaped section is used for combined sewer, and circular section is suitable for economical for large flow. Question 12 is determine the section factor for the channel section having area 20 meter square. Section factor you need to calculate. The area is given 20 meter square. So what is section factor? Is nothing but the parameter which only depend on your geometry of the channel. Only geometry. So what is this? Is your section factor. Z is equal to A root T. How it come? From the Froude number. Okay, so you can calculate very easy because you know the area is where the area is come from your discharge by area at the place of velocity, so you can calculate. So which is your 40 meter. And where is the top width? Question is missing something. having area is this, and top width should also given, the top width given the 4, then you are able to calculate. Okay, so here option C is correct. So now the next is the gradually varied flow is example of, already we have seen such type of question, which is your non-uniform gradually varied flow. Okay, then the dynamic equation of GVF is based on the assumption of GVF assumption. Remember please, assumption, the dynamic equation of the GVF we have already seen in the previous section. The pressure distribution at any section, this is hydrostatic. Air entrainment, roughness coefficient depend on the flow depth, not. So none of the above option will be correct here. We have seen all the questions, so just I'll go through. Already I have told you that is the depth is known as the secant depth before jump and the after jump. So always remember. Okay, question number 4, how many total possible? So as I have told you, mild, steep, critical, adverse, horizontal. So here 3, here 3, here is 2, here is 2, here is 2. So 6 and 6, 12. So option A is correct. Already I have explained earlier. Okay, so next one, the GVF. In GVF, as a value of water depth approach the uniform depth, the water surface meets the, remember this is a very interesting question, in GVF, as the value of water depth approach the uniform depth, remember please, the water surface is meet the normal depth line vertically, meet a very large depth as horizontal asymptote, approach normal depth like line asymptotically, and none of this. So it is asymptotically. How? Here the explanation is given. So dy by dx is tends to 0. Means change in horizontal means dy by dx is nothing but change in the your depth with respect to x. As you are moving in the x direction, how your depth is changing. If it is tends to 0 means as you are moving the x direction, your velocity, your y is not changing. So that is. Next question. Which of the following type of GVF not exists? Which type of not exist? You have the M1, M2, M3, S1, S2, S3. You have the C1, C3. You have the H2, H3. You have A2, A3. So which one is not possible? Is C2. C2 is not possible. H3 possible, A2 possible, M1 possible, C2 is not possible. Why? Because C2 is in between, the two section is in between your YN and YC. In the critical, YN and YC is equal. So C2 is not there. Let us move on the next one. Post jump root number in a horizontal trapezoidal channel is less than unity. Post jump, the question is talking about post jump, equal to unity, more than unity, and none of the above. So as you know, before the jump the supercritical flow, then after subcritical flow. If it is subcritical flow, then your fluid number should be less than unity. Very easy. Next one, question number 8. A hydraulic jump takes place in a 6-meter wide rectangular horizontal channel at a point where the flow depth, this one, and flow number, this is the specific energy at that point in meter. So here you need to calculate the specific energy, and you have the two things. Hydraulic jump take place at a 6-meter wide rectangular channel at a point where the flow depth was this, that is 0.6 meter wide, and flow depth was 0.16, and your fluid number was 2.4, means supercritical. The specific energy is, you need to calculate the specific energy. So how we will calculate the specific energy is y plus, that is y is already given 0.16 v square by 2g. So how we will calculate the V? So if you know the Froude number, that is 2.4, so very easily you can calculate the V, that is G into D, and this is a rectangular horizontal channel, so D is Y, nothing but. So here you can put the 0.16. So from here you can calculate the velocity. Once you will put here, you will get the answer. Very easy, nothing. So this is your 0.62 meter, your specific energy. Now come on the next question. In the above problem, the post jump flow depth is 0.47. The energy loss associated with the jump. I was telling previously we have one question. I have one question based on the loss. What is the loss in between the jump, pre-jump to post-jump? What should be the loss in between? So initially you have the depth is 0.16. Now finally you have in the subcritical 0.47. So in between loss of energy. So loss of energy associated with y2 minus y1 whole power cube divided by 4y1 y2. So after the calculation you will get. And remember, this is about the horizon, your rectangular channel. You cannot apply everywhere. So here is 0.099. Okay, next question is question number 10. So the Froude number at the end of hydraulic jump rectangular, this the secant depth ratio. So again we have already solved this question. Previously we were using the d1 by d2, here y1 by y2, nothing but the classical hydraulic jump analysis of the frictional resistance is assumed to be zero. The classical hydraulic jump analysis, the frictional resistance in the, let us, you are using the classical hydraulic jump analysis you are doing. So in that we need to consider the frictional resistance zero. So this is the question. Now this is the last question for today. The mathematical analysis of hydraulic jump is based on the conservation of momentum. Why? Energy not conserved, energy lost during the your jump. So always remember. So hope you all enjoyed the session. So we'll meet again on next on 15 March. So thank you from my side. So we'll meet again on the next session, that is on schedule maybe 15. Now you can leave the class, no issue. Okay, thank you, Bala.